What's up, rock and roll stars? Welcome to the movie that you are watching and you're the star of because you are the math rock stars. Today we're going to talk about modeling multi-step linear equations. I'm excited for you guys. I think you're going to learn a lot from this, and it's really going to help you with your understanding of how to solve multi-step linear equations without modeling. Okay, what does a triceratops sit on? What does a triceratops sit on? Yep, he sits on his tricerabottom. Love it, love it, love it. If it's got a triceratops, it probably has a tricerabottom. All right, so the target for today is to work on multi-step equations using a variable that can be on one or both sides. It's going to possibly have distributive property. There's going to be all kinds of fun things going on, up to 4 steps, that is. And today we're going to be doing it through using algebra tiles. We're going to be modeling it. Okay, so real quick, what's an equation? Equations are like a balance. The equal sign is the balance point. So we have to understand equations have to stay equal. If we change a value on one side without changing the value on the other side, they become unbalanced and they're no longer equations. They become this other thing called an inequality. We are working with equations, so let's keep everything balanced. Okay, first, let's review the keys that we've talked about before. If you haven't watched one-step or two-step equations, go back and watch them. If you haven't watched modeling one-step and two-step equations, I highly recommend you go back and watch them. Also, combining terms, distributive property, all those videos are back there. You may need them as you go forward. Okay, so first key of solving multi-step equations is understanding inverse operations. Inverse operations simply means we have addition, subtraction, multiplication, and division, and the inverse of them means which one is opposite of each other. Addition and subtraction are opposite of each other. Multiplication and division are opposite of each other. So they are inverse operations. You'll need to know that when you're manipulating an equation. Second, the flippity-flip order of operations. Okay, so simplifying expressions uses GEMDAs. We use groupings. We use exponents. We use multiplication and division, whichever one we see first, like we're reading a book. And then finally, we do addition and subtraction, whichever one we see first, going from left to right. When we're moving across an equation from one side to the other, we flippity-flip it and do it backwards. We do addition and subtraction first, and then multiplication, we go up. Okay. Key number 3 is that when we're using inverse operation, balance is the key, like we said at the very beginning. Whatever I do to one side, I have to do it to the other side. I have to keep it balanced. So if I take 3 away from one side, I got to take it away from the other side. Otherwise, it becomes unbalanced. And review number 4, just understanding the parts of the equation. And this is mostly useful for when we're combining terms, which you're going to be doing. We have to understand that this is a coefficient. It's the number touching a variable that's being multiplied against a variable. What is a variable? It's normally the letters. It's the unknown. What are we trying to solve for? Okay, next we have constants, which have no variables. These are just fractions, decimals, integers, anything like that that doesn't have a variable connected to it. We have an operator. In this situation, it is subtraction. There's an operator in here as well that we can't see because it's 7 times x, right? So addition, subtraction, multiplication, division are all operators. And then finally, we have terms, things that are on the same team. This is a team that wears jerseys that has a number connected to an X. So all their jerseys look like that. Here's another team that has jerseys that are just constants. All right, that's another team. So again, that's in my combining like terms if you don't understand why I'm saying things like teams. It's a good way to kind of represent combining like terms. So here's our new keys, distribution property. Okay, this is when if you see somewhere in the equation, any side of it, where there is a parentheses with a number or even if you have like 3x connected to a parentheses, and it means it needs you to distribute throughout everything inside the parentheses. In other words, using Oprah Winfrey's, you get a 3x and you get a 3x. Watch the video. You do that first. That's the first thing we do. So here's an equation that has a couple sets of parentheses. And we want to do those sections first. So I would go ahead and distribute my -4 throughout this set of parentheses, and I would distribute my -3 around that set of parentheses. We do that before we do anything else. The next key is, the next thing we would do is, before we start doing GEMDAs backwards, is we're going to combine terms. So again, look at one side of the expression, okay? And we say to ourselves, oh, I have terms over here that are alike. I have a 3x and a 5x. I can go ahead and combine them. And then on the other side, I have some constants, a 17 and a 2 that are on the same side. Go ahead and combine them, okay? That's important that we do that. you can skip it and not do it sometimes, but it's just going to make a lot more steps and lead to many more opportunities to making mistakes. All right. So when we model multi-step equations, we always start with a key. Okay, so this is how we show our algebra tiles. Okay, positive numbers we have as rectangles and squares, positive values that is, and negative values we have them filled in. Okay. All right, so let's review a two-step equation model just so we can see how it works. So here's our key, and here's our equation. So first thing we're going to do is go ahead and just put in the values of those parts of those terms. Let's go ahead and put those into our each side of the equation. So I put 2 rectangles there because that's 2 x's. I put 3 positive squares there because it represents plus 3. Notice I did not put a plus sign in the middle there. You don't need to do that when you're showing addition and subtraction. Just use the positive and negative values. I put an equal sign in the middle because this is an equation. And then finally, I put -5. I put 5 filled in squares because each one of those represents -1. And I want to represent -5. Okay. So then what do? Well, for two-step equations, we start right off the bat with backwards GIMDAs. We ask ourselves, as we're trying to get the variable by itself, so how do we get that x by itself? Do you see any addition or subtraction? Right here is plus 3. All right, so yes, we do see addition or subtraction. And if we do, we need to make some zero pairs because we're trying to move those, get rid of those. Okay, so how do I do that? All right, so I go ahead and say, I want to get rid of this positive 3. So I go ahead and put -3. That's the inverse operation. Whatever I do to one side, I have to do to the other side. And what I'm really doing is getting all of my constants to one side. Okay, so when I do that, I got to eliminate my zero pairs. Here was a positive 3. So when I put the -3, a positive 3 and a -3 equals 0. So I can get rid of those guys. All right, then I go to the next thing. Do I see any more addition and subtraction? No. Do I see any multiplication and division? Yes, I do. I have 2 times x. I have 2x. What's the opposite of multiplying by 2? Well, it's dividing by 2. All right, so we're going to do the inverse and divide. And division, when you're modeling, all we want to know is I have 2 x's. All right, I just want to know what one of those x's means. And so what I do is I make 2 equal groups, okay? And then I find out, as long as each one of these x's represents the same value, that's what my x will equal. So here's my x, and it represents -4. So the other x also equals -4, but remember, to solve this, we just want to know what one of those x's equals. So our final answer is x equals -4. Okay? So how can we use that going into modeling multi-step equations? All right, well, we start with a key first of all, and here is our equation, and let's dig in right now. If you haven't been paying attention, it's go time. All right, so the first thing we do is, here is our new method for solving. We distribute. Are there any parentheses in this problem where we can use a distributive property? No, there's not. Well, first of all, let's go ahead and put our values up here. So we have 2x, we have -4, so I put 4 negative squares in. I put another positive rectangle because we have 1 more x. On the other side, we have 3 positive x's and we have 2 positive x's. There's our representation with the algebra tiles. Now, can we get our variable by itself by starting with distribution? There is no distribution in here, so we don't need to do that. Next thing we need to do is combine terms. In other words, do we have members of the same team that we can work with? Yeah, here we have 2 x's and we have another x. They're on the same team. If you ever see a variable by itself right there, that really means 1x. If it was a negative sign, it would be a -1x. So we have a 2x and we have a 1x. And we want to combine those guys. So let's go ahead and do so. Remember, we're only doing one side of the equation. So when you're combining terms, you look at one side, do everything you can combining wise, and then say, okay, we're done there. Let's go to the other side. All right, so the other side, here we have a 3x and we have 2x. 3x's and 2x's combined equals what? 5x. And now that we've done that, we've done step 2 by combining terms, we can go ahead and give ourselves a new equation because we've simplified. Now what we have left is 3x minus 4 on one side, and on the other side we have 5x, okay? No more terms to combine, so we go to the next step, which is moving day. Moving day simply means get all the variables on one side. So we have 3x on one side and we have 5x on the other side. A little hint here, go ahead and move the variable that has something else involved to it over to the side where there is nothing else involved. So we're going to get rid of that 3x. Okay, when we want to move something from one side to the other, okay, and move a whole value one side to the other, we are going to be doing zero pairs. So let's go ahead and move that positive 3x over to the other side. And how are we going to do that? We're going to do zero pairs. We have a positive 3x, so let's put a negative 3x in because those will cancel out, right? 3x positive, 3x negative, 0. All right, but what we do to one side, we got to do to the other side. That's one of our keys, right? So we go ahead and move that negative 3x onto the other side as well. And now let's get rid of all the zero pairs we see. Over here, I had a positive 3x and a negative 3x. That cancels out. Over here, I put that negative 3x in, so I'm going to get rid of these 3 as well. So it's just get rid of some zero pairs. Bye-bye. Bye-bye. And this is what we have left. All right, so now we're down to another expression or equation. We have negative 4 on one side, and we've narrowed it down to 2x. Okay, so how do we do that? Well, 2x means multiplication, right? So now we're doing reverse GIMDAs. We're going to do reverse GIMDAs. There is no addition or subtraction, right? Because all we have is 2x equals negative 4. Nope, there is no addition or subtraction. So then we go to the next one on reverse GIMDAs, which is multiplication or division. Do we see any? Yep, yes we do. This is 2x's, which also means 2 times x. So we're going to do the opposite of that, which is what? Okay, the opposite of that is we're going to divide. Remember in the multi-step or the two-step equation, all we're trying to do is get the value of 1x by making, since it's 2 here, since there's 2 of them, we are going to make 2 equal groups, okay? So there's our 2 equal groups. This x equals negative 2, and this x equals negative 2. So the value to solve this, we only want the answer of one of the x's. So x equals what? Negative 2. And there's our answer. And that's how you solve it. Okay? Distribute, combine, moving day, reverse GIMDAs, get the variable by itself. Boom, boom, boom. Life is good. All right, let's go ahead and fill in some blanks here. To solve multi-step equations, we need to do 3 things before we follow the exact same procedures for doing two-step equations. Okay, the first thing is we need to use the distributive property. Look throughout your multi-step equation and see if you see any parentheses and if there's a way to use the distributive property. Second, after we've done the distributive property, that simplifying and narrowing down our expressions, we're going to go ahead and combine terms on one side and then look at the other side. We're not moving things around yet. Combine all terms on one side and then look at the other side to combine terms on that side. Next, it's moving day, which means get the variable on one side. So you may have 7c, and on the other side of the equation, you may have minus 9c. Whichever one you want to move it to one side or the other so we have all the variables on the other side. And no variables on, so all variables on one side, no variables on the other. And then finally, once you get to that point, you've moved all the variable to one side, and you've got some stuff going on the other side. It's simply reverse GIMDAs, right? We're using two-step equations, our understanding of two-step equations to finish it out. All right. Let's see. Let me get you a good one here today. What do you call a fossil that doesn't ever want to work? Oh, you call it lazy bones. Fossil, lazy bones. I love it. I love it. I love it. Have a great day.